Okay, now we invite you to the session where we are going to demonstrate the assignment related to segmentation. Right? Before we go into the segmentation assignment, let me just first give you, show you how you invoke the virtual box. I hope you have gone through the software installation video which we have loaded in the website, and you have installed the virtual box in the way it should be done along with the guest and the host operating systems. I hope you have done all those things and your laptop is ready. Now let me just show you how we invoke the virtual box. So there will be a Oracle VM VirtualBox logo in your system. Go and double click on that. You can go and ignore it. Now you see a host OS and a guest OS. You should see this. So first go to the host OS and click start. And you will see some auto capture keyboard, all those things. Please close. Please close everything here. And now Ubuntu starts booting. Now it will come to a stage which is the host. There you would have entered a password when you had created the system. So the same password you enter here. And now you see a Linux Ubuntu system, which is your host OS running here. And what you have downloaded here, you would have already downloaded the NASM and also all the assignment files using the Firefox web browser inside this. This we are told as a part of our introductory software installation video. And you would have done that. Now go and click this dash home and you will see the terminal. If you don't see terminal, just type term and you will see terminal here. Click on this terminal. So you see a terminal here. Right. So now you can open another terminal by another tab in this terminal by going to file and say open tab. So you'll have two terminals here. We need that, one for compilation and another for this. Now we are going to do Lab1. So we go to the directory cd downloads and we see cd assignments. Again do cd assignments. Sorry, we are going to do Lab1. So we go to cd Lab1 and there you see 4 files. The lab1.s. The lab1.s is the assembly program. GDB comma is the executable shell script that will compile your assembly program into an extended Linux format, which you will download onto the guest machine and execute it. inp.gdb actually has the commands which we will use to configure the remote machine from the host machine. And protest.ld is a loader file which basically tells where you need to load the software. I will first start with protest.ld. I am saying more protest.ld, that will give you all the things here. Now as you see here, the program essentially says, the file essentially says that load the program at 0x8000. Why we are, so in the remote machine, we are loading the program at 0x8000. Why are we loading it at 0x8000? we are loading at 0x8000 because, as I told you in the introductory lecture for software installation, that the remote machine has a GDB kernel running. So the GDB kernel will be occupying certain space in the RAM, and that is less than, the space is less than 8000 address. So the entire GDB kernel will be occupying the address below 8000. So we will load our program at 8000 and above. So that is what this loader file basically says. Now I will go ahead and tell you what GDB comma has. GDB comma, if you say more GDB comma, it has two commands. First is nasm -felf $1.s. So it will compile. NASM is the network assembler. You would have downloaded it if you had followed the introductory video of installation of the software. You would have downloaded NASM into this machine, so it will be available here. So this will compile the given S file. In this case, our lab1.s, as you see here, will be compiled by NASM and in the ELF format. And then this compiled file will be converted into a loadable file with inputs from protest.ld, and it will give me a file called lab1.out in this case. Okay. So this lab1.out, I will upload it into the guest machine, and the GDB sitting there in the guest machine will load this file into 0x8000 because your protest.ld says that we need to load it at 8000. So let us go through that exercise. First, I will compile this file called lab1.s. What is lab1.s? I am going to explain as a part of this assignment. So I compile that by saying gdb comma. So let us first note what are all the files here. So these are all the files. Now I say /gdb comma lab1, and now you see that lab1.out is already created here. For just I will tell you what is lab1.map. Lab1.map says that there is a file .text in the file which is loaded at 0x, it's of size 0x4000, and this is of the format ELF32. So this basically tells us what are all there in your lab1.s. We will discuss that in great detail when we look at lab1.s. Now lab1.out is basically created. Now this lab1.out has to be loaded onto the bare metal machine so that we understand how this works on that machine. So now we go back to the Oracle VM VirtualBox Manager, and now we will go and start the guest OS machine. Now there it will say GDB boot. Go and press the enter key. Note that in the guest machine I told that there is a simple GDB kernel running, and this is that. So this will be showing booting. So let it be in that shape. So this, if it has crossed, the cursor has crossed that booting ... it is actually already booted. Now what we will do is, we have already compiled this. We will now go to another tab. I said we opened two tabs here. So we will go, we will go to another tab here. So there are two tabs. One tab is for compilation, another tab is for connecting. So this tab we will use for connecting to the remote machine. So I just say sudo gdb. I enter the password because GDB is a privileged program. It works under super user. So you have to do sudo gdb. Now GDB has come up. Now I want to connect to the remote machine. So how do I do the configuring, as I told you, is there in the inp.gdb. So I go to the next tab and you see there are commands here. So first I do set debug remote 1. So I will do set debug remote 0, because 1 means it will keep giving you a lot more output of what it is trying to do with the remote. It will be sort of cluttering your screen. So I will just say set debug remote 0. So you can go do remote 1 and remote 2, and if you keep on increasing this debug level, it will give you more information about how it is communicating with the hardware machine. The next step is, please note here, I am setting remote baud 38400. Note that this machine is going to talk to the host machine through a mimicked serial port. So, and the baud rate of that serial port, we need to set it as 38400. Now this is set. Now this target remote /dev TTY S0. You can actually even press right click and copy this and paste it here also. Right click and it will give you this. Yeah, target remote. So this basically is this /dev /TTY S0 essentially says I am communicating through the serial port. Now I have established a contact with the host machine, with the guest machine, the bare metal hardware, which is running here. So this is the bare metal machine. Now I have my host machine gets is now established contact with this machine. So you can confirm that by this comment 0x888. Now I will give you some very simple interface things. If I put IR, this will tell the content of all the general purpose registers, the segment registers, your instruction pointer and your E flags of your remote machine, that is your guest machine. So by this I can go and find the content of the registers in the remote machine. I can find the segment selectors and also the E flags. Similarly, I can also go and find out what is there in say 8000. X/X means access the memory in the address in hexadecimal format. The output also we need in hexadecimal format. 0x. This gives you the content of 4 bytes. So in 8000, 83 is stored, in 8001 EC is stored, 8002 1C is stored, and in 8003 85 is stored. Now I can also say X/2X 0x 8000. So this will give me 4 bytes. Right. So in 8000 again 83, 8001 EC, 8002 1C, 8003 85. Now it can go and say 8004 is D2, 8005 is 7F, 8006 is 1F, and 8007 is B8. So I can query the memory, I can query all the general purpose registers. So this is basically the debug interface that we will have. Now what I am going to do is I have already compiled lab1.out. So I am going to load lab1.out here. No. So why this file directory is happening? Because I have not moved to this directory. So just I exit GDB again or quit this GDB. Use the word quit. Exit doesn't work. Quit. Now I am in VirtualBox. I need to again go to downloads here. I need to go to assignments, again assignments, and then lab1. Now you see I have lab1.out here. So so now I can say sudo gdb. GDB is already here. Now I could set debug remote 0, set remote baud 38 400 target remote / dev / tty s0, everything is there. Now I say load lab1 dot out. Now it is loading. Now you see that this program lab1.s is of size 4000, and so we are really mimicking the serial port. So now you see that there is some error message. So there is an error in communicating. So again I load it. So every time you may have to load it once or twice. Once you get this transfer rate, these three commands, now you have successfully loaded. Now we have successfully loaded, and now we can start the assignment in detail. Okay. Now let us go to